Welcome to DC circuit analysis, superposition principle, with analogous concepts and examples. Superposition principle can be expressed in this definition. The net response f of x plus y plus so on and so forth caused by two or more stimuli is the sum of each stimulus individually. Okay, so basically we have this expression x plus y plus k is equal to f of x plus f of y plus k. Now this is applicable for linear systems, either time varying or time not non-varying time systems. For example, we have here a loading of beam. We have two loads. The first one is the uniform loading with 10 kilonewton per meter, and then we have a single load at 50 kilonewton. Now this system is equivalent if you add the two systems. First, the uniform loading plus the single loading. So if you add the two systems together, then you will have this behavior, the general system. Another example is we have these weights. If you have a system like that, you have the trusses or the members, okay, representing one system. So if you have two loadings, that system is equivalent to the summation of individual loading. Okay, so that's basically superposition principle. So this only apply for linear systems. Now for circuits, it's very important. Okay, recall in the nodal analysis example, we have this circuit. Take note, you have two sources, meaning there are two sources energizing the circuit, or there are two supply, in this case voltage supply. There are two voltage supplies in this circuit. This is equivalent if you add the two system first with the 10 volt source and the 15 volt source. So combining these two systems, you will end up with this general circuit. So then how do we apply superposition principle? So let's solve that example. So remember in your nodal analysis, so if you haven't watched the nodal analysis DC circuit analysis, then I would encourage you to watch that video. Okay, so conducting KCL in every node. So we have two nodes A and B. So you have two equations. Take note, we don't conduct KCL in the reference node because the voltage in the reference node is equal to 0. So that's our assumption. Okay. So then we have equation number 2, node B. So we have this equation conducting KCL plus the Ohm's law. Okay. So basically we added all the currents, but the current is represented into voltage and resistors. Then we have these equations. When we arrange the two equations, equation 1 and 2, so you have VA plus with the coefficient plus VB is equal to 5, and then the other one is equal to negative 15. Okay, so that is how we conducted nodal analysis in our previous example. Now for superposition principle, simply look like this. So it is equal to this system without the 15 volts, okay, plus the system without the 10 volts. Similar process, we use nodal analysis. So node A, we have this equation almost similar to the general circuit, okay, because they are the same in the node A. In the node B, so notice the difference. So there's no 15 volts in that example. Okay, so then that's our equation 2. So arranging the two equations, we assign VA prime and then VB prime. So this is not the same as the original one for VA and VB. Okay, so just simply assign prime is another variable in that case. So take note, the only difference if you look at this equation is the 0 here. Okay, and okay, so you have the first set of equations for the first set of circuit, and then for the second one we have these equations. And take note, the 10 here becomes 0 because there's no 10-volt source in that branch. Okay, so for the second node, so similar to the second equation. Okay, and arranging the equations, we have VA double prime and then VB double prime. So I just added prime, double primes, just to show that VA prime and VA double prime are not the same. Okay, and also the same with VA and VB, they're not the same. Okay, so having done this, we have two sets of linear equations, systems of linear equations, this one and then this one here on the other side. So you have two sets. Now, superposition principle tells us that VA, okay, the general equation in the general circuit, is equal to the summation of VA prime and then VA double prime. The same is true for VB. VB is the sum of VB prime and VB double prime. Sorry, this should be VB double prime. Okay, that's it. So if you have multiple sources, whether voltage or current source, okay, so the number of sets, in this case we have two sets, so the number of sets depends on the number of sources. Okay, determine the number of linear equations. Okay, in our previous example we have two sets of linear equations. So now here we have a general expression. This one is the variable, these are the coefficients, and these are the constants. So the variable can be voltages or currents. This time we're talking about circuits, and this is for circuits. Okay, but take note, it cannot be applied to power calculation, so it cannot be like that. Okay, so if you would like to get power, first you solve voltages or current. Okay, now pretty simple. So you just simply replace X with either voltage or current, and then you will have your answer. Why is this important? We will see in the next lessons. Basically, we will apply this in Thevenin Norton circuit analysis or circuit simplification, but it's good to understand this in a general sense. Okay, thank you so much for watching in Superposition Principle.